thin lenses. This is the topic in IGCSE Cambridge Physics 0625. So we are going to have a candid discussion on how you're supposed to answer different questions as far as this topic is concerned. And if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. In order to access our papers and this document you can see I'm having here, you can be able to join our Patreon page, whereby you can be able to download all these documents that I'm displaying at this particular point. Without much ado, let's just dive in so that we can be able to see the kind of question that have been asked in years before in this particular topic of refraction of light and also thin lenses. In this particular question, we are supposed to draw two rays from the top of the object incident. There are two rays from the top of object incident to the lens as shown on the diagrams. And then on the diagram, continue the path of these two rays to show the position of the image for this particular object. So now here we have the object. The diagram is a full-size ray diagram showing the formation of image by thin lens. Then circle items in which they describe the nature of the image formed. So we are having the object and then we have the image here, so which means that we can be able to pick a few things about this particular image that we are having here. So what we need to realize that this image is upside down compared with the object here. So which will mean that we are going to say the image is inverted because it's upside down. And also something else we need to notice here, the image is bigger than the object. Then we can be able to say the image is basically enlarged. That's what we are going to say there. Then we are going to say the image is real because it's formed by real rays. We are not, because the image is formed by real rays. So that is something that you are to remember. State one feature of a visual image. One of the features we are going to say is that it cannot be casted, or it cannot be formed on the screen. Cannot be formed on the screen. At the same time, we can be able to say visual images are formed by imaginary rays. Formed by imaginary rays. So those are a few things that you can be able to remember in that case when we are talking about visual images. Moving on with the paper. Here they are asking determine the focal length. So the examiner was trying to check, do you understand where the focal length is? Because we know any ray that passes parallel to the principal axis is going to be refracted such that it passes through a point on the principal axis, and that's where we have the principal focus. So if we want to find the focal length, we're going to measure the distance from the center of the lens to where the F is, and this is going to give us 2 centimeters. This is going to give us 2.0 centimeters, 2.0 centimeters in that case. Now, we are also given another question here, whereby we are told on the diagram make label, mark and label F, which is a point where we have the focus. But we are told that the lens has a focal length of 3 centimeters. So we know that the one box represents 1 centimeter. So meaning this 1 centimeter, 2 centimeters, 3 centimeters. So we shall have our F at that point. And also here we shall count from this other side, 1, 2, 3. So our F also will be at that given point. So which means now that we have our focal principal focus, then we can be able to draw a ray and show the position of the image. Yeah, So how do we do that? We are going to draw a line that is parallel to the principal axis from the top of the object like that. That is the first line. And this line that is parallel to the principal axis is going to be refracted such that it passes through F. So we are going to put like that, and then we are going to extend our line going like that, passing through the point F there. Another ray of light that is going to be used to locate the image is a ray of light that passes through the principal from the tip of the image through the center of the lens like that. But if you can notice what's happening here, these rays that we are having at these given points are diverging. So when these rays are diverging, it means there's a possibility that they are going to meet behind the mirror. So, or this converging lens. So we are going to extrapolate that line backwards like that, and also this one we are going to extrapolate it that way, so that we can be able to locate like that. Yeah, so you have to ensure you do it quite accurately, and you can see now they are going to meet at a given point here. So since the rays that have created this image that we are talking about here are broken or are virtual, then it means I'm going to have my image dotted because it's now a virtual image. State and explain whether I is real or virtual. This is virtual because it's formed using virtual rays or virtual rays or imaginary rays. Yeah, so that's basically what we are going to put into consideration when we are answering this. State the name given to the lens used in this way. You can see the object size is smaller than the image, so we can say this is magnifying. Lens. Magnifying lens. Yeah, so you can say it's a magnifying lens. So if you are new to ProfLearn, consider subscribing so that anytime we are going to do more tutorials, you'll be notified. And don't forget to check our Patreon page and also join there so that you can be able to download these papers that we are having at this given point. Now, without much ado, we can be able to continue to the next question and get to see how you were likely to have approached more of questions. Now, the focal length is 3.0. Rays of light parallel to XY are traveling towards the lens. So they are not really telling us which rays, but we can be able to say there is a ray traveling towards the lens like that, and there is another ray. We can be able to say anywhere, we can just locate it anywhere, but they are telling us just rays are traveling toward the lens like that. And a ray, when it's traveling, basically that ray is having an arrow that way. Then if they are parallel, then they are going to pass through the principal focus 3 centimeters. 1, 2, 3. 3 will be here. That will be the principal focus. So the first ray is going to pass through that point. After refraction, is going to pass that way, and the other ray also is going to pass through the same point because the two rays were parallel. So also this ray is going to pass the same way. So you can see the two rays are going to converge at their point, and that point they are converging is the principal focus. So describe what happens to the right after it passes through the lens. After they pass through the lens, they converge at the principal focus F, which is 3 centimeters from the lens, and also they converge at the principal focus. Again, they diverge from F, from that particular point that we've identified at this given point. So basically that is exactly what's going to happen there. And then you are asked to state the meaning of monochromatic light. What is the meaning of monochromatic light? This is light of a single frequency. This light of a single wavelength. Yeah, this is light of a single wavelength that we're going to have here. Now we have question 8, and we're told the diagram is a full-scale diagram showing converging lens. The two principal focuses F1 and F2 are indicated here. And then on the diagram, draw two rays. This is the object. So if that is the object, the first ray that is used to construct right for the ray diagram is going to be a line that is the lens, and then this is going to be like this. Let's see. Going to run that way. Yeah, so what do you notice? The ray are diverging. This one is diverging, so the rays are actually moving away from each other. So the only option that we have here is just extrapolating the rays backwards. Yeah, so if you can look at this keenly, open your eyes widely, you realize that the rays are going to appear as though they are meeting somewhere behind here. Yeah, you can see. Yeah, so they are meeting at a point here, and our image is going to be formed there. This is going to be our image. Yeah, so what are the characteristics of the image formed? Image length, we are going to measure this. This is around 2 point, this is 2 point, which value is that? Image length is around 2.7 centimeters. And then we are supposed to write the characteristics of this image that we have here. Number one, the image is bigger than the object, so this is magnified. The image is same sense of direction. Both of them are facing downward, so we can say same way up as the object. I know some students will make a mistake and say upside down compared. No, you can see this is facing down, also this is facing down. Yeah. Then also we are going to say the image is virtual because it's formed by imaginary rays or dotted rays, or virtual rays, and this image can never be casted on the screen, never be formed on the screen. So those are the key areas that you really have to remember as this is concerned. We are done with that. We have located the length of the image, and then we have stated the characteristics of this particular image. Moving to question number 9, also is a question that is commonly asked, and here we are told that the diagram shows a ray of light passing through an optical fiber, whereby we are told that optical fiber is made of glass that has the refractive index of 1.4. so we are given refractive index. No light refracts, so meaning total internal reflection takes place at point P and point Q. So we are supposed to calculate the minimum value of I. Yeah, so minimum value of I, what is this going to be equivalent to? So something that you need to remember is that sine of the critical angle is equals to 1 over the refractive index. This is the relationship that you really must have remembered in order to earn this mark. Yeah, so meaning for us to find